Ladies and gentlemen, welcome to a session. And today's topic is a very simple and a quick one. We want to look at electromagnetic waves. Now, remember this concept, it deals with the particles that are charged. So what you should bear in mind is when a particle is charged, it starts moving. When it is moving at a constant speed, it creates electric field. And so when the electric field is being created, as that continues, it ends up creating magnetic field. So now when both electric field and magnetic field are disturbed, they produce waves or radiations, which we call now electromagnetic waves. So in simple terms, electromagnetic waves are waves produced by changing the electric and magnetic fields. Now, what you should know about electromagnetic waves is that electromagnetic waves can travel in a vacuum. That is one of the characteristics of electromagnetic waves. They travel in a vacuum. So it means they may be different. Actually, they are different from sound waves. Sound waves only require a medium for them to move. But for this, they can move without a medium. The number two, electromagnetic waves, such as radio waves, these are transverse waves, meaning that the vibration of a wave is perpendicular to the direction of the wave. That is another key concept that you should know. Another thing that you should know about this wave is that the speed they travel in a vacuum is 3 times 10 to the power 8 meter per second. That is another characteristics of this waves. That's what it means. Now, these waves, they are all interfered. They can be disturbed and then they change. That's what you should bear in mind about these waves. Now, what I'm going to show you, it is exactly the arrangement of these waves. Now, what you should bear in mind is that when you look at this wave, it's gamma rays, X-rays, ultraviolet, light, infrared, microwaves, radio waves as the last one. Now, what is remarkable about these things? We just want to look at two key concepts here. And the first concept that we are looking at is, let's try to move from this side going the other side. What is it that you're noticing? When you're noticing that here, the amplitude, as you go further, it is decreasing. The amplitude is doing what? Decreasing. Now, this has an effect on frequency and wavelength. What do we mean? When you see something like this, it means here, the frequency of something is very high. But when it goes like this, because the amplitude is reducing, the frequency reduces. So it reduces from gamma rays to radio waves. That's how frequency reduces. You get the point, eh? So now, if frequency reduces this way, then what about wavelength? Wavelength itself, as we are moving here, we are saying that wavelength is the distance between two successive crests. When you look at the first crest and the second crest, the distance between them, and when you compare these, the distance is very big. So meaning that when you are moving from here, the wavelength increases. But when you move the opposite, the wavelength reduces. So meaning that the frequency here reduces as we are moving from gamma rays to radio waves. But for wavelength, it increases when you are moving from gamma rays to radio waves. And the opposite is true. So that is a key concept you should understand about electromagnetic waves. Now, for the sake of the exam, you should know how they are arranged. This is a logical arrangement of them based on their frequency and wavelength. Thank you so much for watching.